Hi all of you. So today I am going to discuss one PYQ question. This is from 2023. The concept is capacitors. So just it is a different problem, but easy problem, but try to understand here what. If you know the concept, okay, well, you can understand the question, you can do easily here what. First, what is the question it is given here what? A parallel plate capacitor with width 4 centimeter, length 8 centimeter and separation between the plates of 4 millimeter is connected to a battery of 20 volts. Nothing but one parallel plate capacitor is here. Okay, area of the plate is given like width is here what? Width of this plate is given 4 centimeters and length of this plate is given as 8 centimeters. Separation between the two plates is given as 4 millimeter. Then this capacitor is connected to a battery of 20 volts. This capacitor is connected to a battery of 20 volts. And some more question, right? So a dielectric slab of dielectric constant K, that is given as here what? Phi, having a length 1 centimeter. So dielectric slab of length is given as 1 centimeter. Width is given as here what? 4 centimeter. And its thickness is 4 millimeter. Is inserted between the plates of parallel plate capacitor. Between these two plates, one dielectric material is placed. Of thickness is what? 4 millimeter. Width is what here what? 4 centimeter. But length of the dielectric material is 1 centimeter. Now, the electrostatic energy of this system will be, is asking finally, energy of the parallel plate capacitor is asking. After introducing a dielectric material of dielectric constant phi and its dimension also given 1 centimeter length, 4 centimeter width, thickness is 4 millimeter. So this is the diagram, that is actually diagram is not given in the question. We have to assume or we have to imagine regarding here one. So from this question we can imagine that this is the maybe diagram here one. So if you understand here, see, this is the one plate of the first capacitor. This is the one plate. And this is the plate of the, okay, same capacitor, another plate. First plate, second plate. Now, length of this plate is given as here how much? This is here what? 8 centimeters. Width of this plate is given as here what? That is 4 centimeters. And separation between these two plates is given as here what? 4 millimeter. Right? Understood here what? This is the one plate here having a length 8 centimeter and width 4 centimeter. And between the two plates, width or separation is here what? 4 millimeter. Okay. And a dielectric here what? This is what is the one dielectric material. Okay, there is one dielectric material having a dimensions what? Length of this one is 1 centimeter. So length nothing but this one only. So length of this dielectric here what? 1 centimeter. Width nothing but here what? As it is how much area, right? What is the area of the plate that is equal to this one or not? This one is same. Nothing but, so width of the dielectric and width of the actual plate is also same, that is 4 centimeter. Now 4 millimeter, okay, thickness, 4 millimeter thickness nothing but, so this is the here one, So when the dielectric material is placed between these two, thickness is nothing but the word separation between the plates only indirectly. Nothing but that is also given as here what 4 millimeter. So the dielectric material of constant phi is completely filled between the two plates at a height of here what 1 centimeter. Okay, length of that one is what? Okay, 1 centimeter. So width is same, thickness of that dielectric is also same as the separation between the two plates. Now we have to find the capacity of this combination, and then we have to find the electrostatic energy or electrostatic potential energy of that combination. I think understood all of you. Now first we have to discuss how we can find the capacity of this combination. If you observe, this is here what? This one is without any dielectric. This portion is here what? With dielectric. Without dielectric capacity, this one I am assuming here what? C1. With dielectric, I am assuming this one is what? Here what? C2 capacitor. When these two are arranged without dielectric, with dielectric, this is, if you observe, this one is without dielectric, this is here what? With dielectric, these two are, okay, in a parallel only. So parallel nothing but the one, this one, two are here what? In parallel. So C equivalent we can write, that is equal to C1 plus C2 only. So what is C1? What is C2? Okay, if you find, then directly you can add, then we will get C equivalent. Okay, so then after what we have to do, we will discuss later. Now solution for this question, what is here? First we have to find the C1. What is C1 here? Try to understand here. The values are also given. Not only the formula we have to remember, here the values are also given here. Right. So total length of this area is, okay, total length of this plate is 8 centimeter. The dielectric, okay, material having a length 1 centimeter. Okay, after this, what is the length of remaining here? What? 7 centimeters. So without any dielectric here, length of the plate is 7 centimeters. Width of the plate is here what? 4 centimeters, and separation between them is 4 millimeter only. Without dielectric, we know that one. What is the formula for capacity of parallel plate capacitor? We know what the formula? A epsilon naught by D only. What the values are given here? The word A area means, A means here the area of the plate without any dielectric. Area of the plate nothing but width into here what? Height, length into width only, you know what? Length into width. What is this one here what? 7. 7 into 4. Both are in centimeters only, no problem. That is equal to what? 7 length into breadth. Okay, that is our area. But both are in given here what? Centimeters. So centimeters nothing but 10 to the power of minus 4. 7 into 10 to the power of minus 2 into 4 into 10 to the power of minus 2. 7 into 4 into 10 to the power of minus 4. So keep it as here what? Epsilon naught as it is, because of the answer is asking in terms of epsilon naught only. J nothing but joules. Energy is measured in joules only. Divided by D. What is D here? D is the separation between the two plates here. What is the separation between the two plates here? Already it is given. Separation between the two plates is what? 4 millimeter. 4 millimeter nothing but 4 into 10 to the power of minus 3 meters. Here we can cancel here the one. Okay, 4, 4. 10 to the power of here what? Minus 3. 10 to the power of minus 3. So finally it will be get here what we will get, that is equal to 7 into, okay, we will write here. So that is equal to 7 into 10 to the power of minus 1 into epsilon naught. This is equal to 0.7 epsilon naught. Okay, this is the word C1. Next what you have to find? C2. C2 means with dielectric here. Already we know that one. With dielectric, what happens to the capacity of parallel plate capacitor? That is Ka epsilon naught by D. What is the K here? What? K, for the first formula, Ka epsilon naught by D. Okay. That is equal to Okay, what is the dielectric constant is given here? What? 5. That is 5 into A. Area of which one we have to take? Area of this dielectric material, whatever it means, this capacitor area we have to take. So, area of this one nothing but is the what? Length of this one 1 and width of this one is 4. So, 4 into 1 into 10 to the power of again minus 4. This is the area. Into epsilon naught divided by D here. D is again nothing but for this one also thickness is same only. Na? So that is the reason why we can take it as it was same like that. That is 4 into 10 to the power of minus 3. What will cancel here? One? This one is cancelled. So this one also here one we can cancel minus 1. So finally what will get here? 5 into 10 to the power of minus 1 into epsilon naught. This is nothing but here what? 0.5 into epsilon naught. Okay. So finally C1 is equal to 0.7 epsilon naught. C2 is equal to 0.5 epsilon naught. We have to find what? C1 plus C2 only because of both are in what? Parallel only. Okay. Finally C equivalent is equal to C1 plus C2, that is equal to 0.7 epsilon naught plus 0.5 epsilon naught. This is equal to, what we get here? 1.2, okay, 1.2 epsilon naught. This is the value of here C equivalent. This is the value of here C equivalent. So after connecting here, after placing a dielectric of this one, so total capacity of this combination is equal to 1.2 into epsilon naught. But it is asking not only the C equivalent here, it is asking what? The electrostatic energy or electrostatic potential energy of this system is asking here. So we know the formula of that is here. What is the formula of electrostatic potential energy? That is U is equal to 1 by 2 CV square. That is nothing but C equivalent here. C equivalent V square. What is the V here? V is already given. Between these two plates, one battery is connected. That is like this. This is the one plate here one. This is the another plate. Now this plate is connected. That is like this with a battery of like this. Now how much voltage here? That is what? 20 volts. This is the one? 20 volts here. Of course that is like this. Now you can write here what is the formula for this one here? 1 by 2 C equivalent V square. That is from potential energy stored in a capacitor here. C equivalent already we know that. C equivalent how much we got here? 1.2. So that is 1 by 2 into 1.2 into epsilon naught into V. What is the V is given? 20 volts. Okay, 20 into 20 nothing but what? Of course 20 into 1? 20. So that is equal to so 2 ones are here 1, 2 tens are here 1, 200. 200 into 1.2 into epsilon naught into here what? 200. Okay. So answer of this one here what? That is equal to what is the answer here one? That is 240 into epsilon naught. This is the energy, nothing but it is measured in what? Joules only. So final answer here one. Energy, electrostatic energy stored in that capacitor U is equal to 240 epsilon naught joules. So they are asking here what? Epsilon naught joules is given. So we have to write only here. This is a numerical type question. That is 240 is the answer of this question. I think all of you understood here one. Okay. So thank you one and all.